to help prepare you for exam number 1, I thought I'd go over all the skills that I've identified as part of the first 8 lectures. You can find these skills at the end of each individual lecture, but I've grouped them all together here. Some of these skills you need for the homeworks. Some won't actually be tested on the exam because they're only involving computer programs. But the rest are fair game, and I expect that you've mastered these skills by doing the readings and doing the homework assignments and, most importantly, the self-assessments. So, in no particular order, let's get started. There's a set of skills. Each one is labeled and numbered. You can find those on the skills page. And let's go through some of these as it begins. There's a number of basic mathematical operators in Python. You know how to add two numbers together naturally, and subtract and multiply. The two new ones to Python that I would imagine are the exponent, which is, you know how to raise a number to a power. So 9 times 9, of course, is 81. But I could also have said 9 raised to the second power is 81. If you know about exponents, you know they can be negative as well. So 9 raised to the negative 2 power is 1 over 81. The one operator that always plagues beginning students is the divide. And I spent a lot of time on it in all the lectures as well as the homeworks because every programming language has to figure out what to do with divide. And in general, the way that it works in Python is that the type of the values determines how to apply the operator. If I have a number like 6 and I divide by 2, it's no big deal. The answer is 3, of course. That's integer division. 6 divided by 2 gives me 3. But what if I have a number that's not evenly divisible? 7 divided by 2 also gives 3. And this is a fundamental observation of the divide operator as it's applied to integers. It expects to take an integer, divide by another integer, and the answer will be an integer. And so what it does is it truncates. It doesn't round. Truncating is clean and simple, and everyone can understand what it is. If you truly wanted to have 7 divided by 2, and you wanted to have 3.5 as your answer, then you have a couple choices. You could either say 7.0 divided by 2, because now this is a floating point number divided by 2. You could also have said 7 divided by 2.0. And as some people have realized, you can take a number like 1.0 and multiply it by 7 like this, and if I read left to right, it takes a floating point number 1 times 7. That creates a floating point number, which divided by 2 is once again a floating point number. On one of the self-assessments, when doing the square root of a number, you have to be very careful not to say something like this: 25 raised to the 1/2. 12. Where do I get 12? Well, let's look at this. 25 raised to the first power, that's the first part of the equation, is of course 25. Divided by 2, and you get 12 in integer arithmetic. Oh, you think to yourself, that's all right. I know I have to make sure to put 1/2 in a parenthesis. This time I get 1. Doesn't make any sense, but of course it does when you recognize that 1 divided by 2 in integer arithmetic gives you 0. So if you really want to have 25 square root, the easiest thing to do is to say raise 25 to the 0.5 power. And after all, as you look at this is now a floating point, so the whole thing is going to be a floating point, which gives me 5.0. There's your basic mathematical operators. You also know how to print information to the console window. We've seen this before, and anytime I need to make information available, if I say x is equal to 6, all I know is the value has been set and I don't have any output to suggest otherwise. But if you say print x, then the current value of x will appear just like you see there. Printing is useful in a program when you want to print to the user eyes information that they need to read. You don't have to just print a variable, you can print an entire equation, the square root of x, for example. Print will put everything on one line, and if you want to put multiple things together, all on the same line, you have to use concatenation, which is another one of our skills that I've expected people to know. Skill SM3, how do you concatenate string literals? I'll describe that here because it's relevant. If you want to say on a single line the phrase something like x is equal to 6, well, To say all that in one line, I have to somehow concatenate together two different strings. So if I take the string x is equals 2, and I concatenate that with the string 6, then you'll see exactly what I want to see. However, if you try to concatenate those together like this, it will complain, Python will complain, because the first part is a string literal. I know it is because it has the quotes around it. The second part is, unfortunately, an integer value, and I can't concatenate strings and integers. So to do this properly, you need to know how to convert floats and integers into a string, and I've shown you that using the str command. So this will now be the string x is equals 2 concatenated with the string expression strx. And as you can see, it all appears on one line. So to put this all in a program, you would say print, like that. And this will indeed put it all on one line. There are different variants of print in Python. Some of you have found them on your own or through the reading of the online textbook. I don't really care which one you use, but I just want to make sure that your program works properly, and I will try to be consistent in my use of using print with string concatenation. Let's move on. You know about the if statement, and the if statement lets you determine whether a value is equal to or greater than or less than another value. This is the way you can conditionally change your execution of a particular program. For this to work, let's start with x again, which is 6. If it turns out that if x is greater than 2, then I want to do something. Note here that I've taken advantage of Python's ability to indent to represent the fact that this is a sequence of statements that all have a chance to execute only if x is greater than 2. But if x is not greater than 2, these two statements will not execute. And as you can see, since x is 6, then I'm going to print these two lines one after the other. The if statement has a very simple structure, but you can use it in interesting ways. So I could also say if 2 is less than x is less than 10, this would work. This logical condition, which is either true or false, in this case I know it's true, and so I know that this is going to print out yes. Oops, let me close it off. So what I've really moved into now is a discussion of logical conditions. And Python has a number that is standard in any programming language. Is 2 less than 10? The answer is true. Is 2 greater than 10? Nope, that's false. How about 10 less than or equal to 7? That's false. But you have to make sure that you don't have a space in between the lesser than sign and the equal sign. They have to be right up against each other. So my basic operators now are less than, which is true here. You've seen less than or equal to. I can do greater than, and also greater than or equal to. You can also do not equal. And there are two different ways of doing not equal in Python. One of the more common ways that you've seen in some early textbooks in mathematics is to do less than greater than. Put those two together, and this says 3 is not equal to 10. That is a true statement. The other syntax comes from C and Java, where you put together an exclamation point in front of the equal sign. And this is called bang equals or not equals. So if I'm reading this left to right, I'm asking for the logical expression, is 3 not equal to 9? And that logical expression is a true statement because 3 is in fact not equal to 9. Once you know how to do if statements, the next thing is to move on to the else statement, which allows you to put together a sequence of alternatives, and you can guarantee that only one of them will execute. Let's put this together into a actual bit of code here because it's useful to see how this works. If x is 10, I can say the following. If x is less than 5, then I want to print out smaller than 5. Else, larger than 5, which is great. Let me save this and execute it. And you'll see here, since x is 10, the first part is not executed, but instead this part is executed. This is a really nice ability to be able to choose either this or that. In the next module after the exam, I will show you another variation that allows you to chain together a number of these if statements one after the other to handle multiple continuous alternatives. But this is the basics that I need you to know for this particular exam. When you look at an if statement, you know for sure that either the block of statements here will execute or the block of statements here. They both can't execute. And when it's done, it will move to the very last or the very next statement at the indentation level of the if. So in both of these cases, after you run it, regardless of whether x is less than 5 or whether x is greater than 5, you know that it's going to either do this or this, but then it will eventually always do this. There's the else statement.